Hi all, Dr. Clark here. Today I'm going to go over lab number 1 for general biology. And lab number 1 is just kind of an overview on how to write lab reports, okay? How to write scientific lab reports. Now, every class is a little bit different, but for the most part, scientific lab reports kind of take the same shape. Okay? And that shape is really based on scientific literature. Okay? So what does an actual scientific article look like? Or what would a scientific article that's published in a journal look like? That is kind of the shape that a lot of lab reports look like, okay, or take place. Now some, maybe in other courses, maybe you only have to do the introduction this week or the methods next week, or these kind of things. But collectively, you're building on one big kind of lab report. Okay? So going through this, a title is very important, okay? And that title should be concise but descriptive. So in other words, you need to let the reader know what topic you are exploring. Okay, what topic is the paper about? Now I know, like in English and some other fields, a catchy title will get the reader's attention and get them to stop and read the paper. But in science, it's not about being catchy. It's more about being concise enough but descriptive enough that people who are interested in your topic are going to read it. Now that might not be the case all the time. Sometimes there's really catchy titles in scientific articles, but for the most part, it's telling the reader what is to come. Okay? What's the paper about? Okay? The abstract might be the most important piece of the paper. The abstract is, especially in scientific literature and scientific writing, is what people read after they read the title. So the title is enough to kind of pique their interest, okay? Then they start reading your abstract, and your abstract should have the highlights of your paper. Should have some background information about why you're doing the study. Should have a little bit about what you did, especially if you did some specialized techniques. And it should have some results, the most interesting results, okay? And then it should have some discussion, some conclusion of why this should matter to anyone, okay? Why would you, care about this paper? And that should all be in kind of less than 250 words, okay? It can be very difficult to write, but a good abstract will get a reader to read it and then say, okay, I need to read this entire paper. This is a paper that I need to read. That's your goal when it comes to writing a good abstract. It's an overview of the entire paper, okay? But it's the highlights of the entire paper. Introduction is where a lot of students and individuals who are writing scientific lab reports and things like that, this is where they get in trouble. In trouble in the sense of this is where they plagiarize, okay? Because most of your introduction, or a good portion of your introduction, is going to be background information. It's going to be information that gets the reader up to date on why you're doing the research that you're doing, okay? And you have to, stand on the shoulders of the people before you. So you have to give credit to the individuals that have already laid down the baseline of this research, and that's where background information, and that introduction can get people in trouble. So you want to lay it out. Normally you want to be as broad as possible, okay? And then start becoming more specific and more specific, all the way into really what's your hypothesis for your research, what's the objectives for your research, what's the predictions for your research, and that should go into the introduction, okay? Methods. When it comes to methods are not just a list of things that you did to complete your scientific research. Okay? A method should be in paragraph form. It should be written as steps, sort of, but not steps in the sense of step 1 we did this, step 2 we did that. Instead, it should be flowing. Okay, so data was collected on this day. This is how the data was collected. Be very specific. Okay, yet don't. You don't have to go to the point where if you're telling someone how to write, a letter, you're not telling them that they have to push the button to make the pen, work, okay? Or they have to sharpen their pencil, okay? So there are some steps in scientific writing that you really don't need to tell the individual, okay? If you're, unwrapping, or if something is in, plastic wrap, okay? You don't have to tell them to take it out of the plastic wrap, unless it would be confusing otherwise. But the method should be specific enough that anyone with a little bit of scientific background should be able to complete your study the same way you did, okay? And hopefully get the same results. Okay? So you need to include the temperature that this study was done at. Okay, so if you're incubating things, you need to tell them that it was incubated at 37 degrees Celsius. Or if you measure things with a ruler, you need to let them know, well, was it a plastic, like a ruler, or were you using calipers, and what degree were you measuring these at? Was it tenths of a centimeter? Was it hundredths of a centimeter? Were you using a micrometer inside the microscope, okay, to get these measurements? So you kind of need to let the individual know the tools that were used to complete the research, but that's not listing the tools out. Okay, you're talking about it within the paragraphs. Okay. The results. Okay? Results is where you're going to give your findings, what you found as a researcher. Most of the time, results start off very basic. Okay, so just basic information, basic results, kind of broad results, and then become much more specific as you move on. Okay, remember that when you're giving results, that it shouldn't just be enlisted, we found this number, this number, this number, this number. Okay, a lot of that information, a lot of those numbers, even statistical tests and things like that, can be presented in tables and figures. Okay, now for tables, if you've created a table, the caption needs to go above the table, and it needs to tell the individuals, if you have any abbreviations in the table, it needs to tell them what the abbreviations mean. If you have, we use solution 1, solution 2, solution 3, it needs to let them know what those solutions are. Okay? And it also needs to be referenced inside the text material. So, if you're talking about testing 3 different solutions, you're going to be talking about the results in your results section, and maybe even in your method section you're going to link to that table so people can find that information. Okay? Figures, that these are often graphs or pictures and these kind of things. The caption goes underneath the figure. Okay, and same thing, you need to tell them what, if you have certain values on the x-axis and x-axis and certain values on the y-axis, what are the measurements? Okay, is it per minute, per second? Okay, so what does it mean? Okay? Especially if it's confusing, or if you know what it means, but the only reason you know what it means is because you abbreviated it. Okay, so allow the reader to know what the abbreviations mean. And if you have p-values or statistical tests that are incorporated in your figures, okay, make sure the reader knows what statistical test was done to get that p-value, okay, and whatnot. Okay? And then moving into the discussion is where you're going to discuss how your results compare to others. But first, you kind of want to talk about how your results either support your hypotheses, okay, or have allowed you to progress with your objectives, Okay? And then kind of get more broad. Okay, so with the results section, or with the discussion section, you really want to start off fairly specific about what exactly you found and why it's kind of important, okay? And then move it more broad into kind of real world issues. How does this compare to what other people have found? Okay, what kind of avenue will it open? What doors did that research open for future research? Okay, and then references, again, you know, you're going to have references in your introduction. You're going to have references in your discussion, and sometimes you'll even have references in your methods. If you're using methods that are well established, a lot of times you can place those, you know, citations in your methods, so you don't have to repeat, you know, the methods that someone has already done, and you're just using the same methods that another research group did. Okay? Again, a couple ways to do references. You know, you can do the superscript reference, okay, where it's a number that's linked to a citation, a full citation, author, title, okay, you know, the editor if it's a book, or the company that published the book, the publisher, okay, the page that that material came off of. If it's an article, then what journal was it published in, what page, kind of, you know, that kind of information. And then the second version is to use last name and year of publication. Okay, both are accepted widely. Okay, most journals will use one of the two methods. Okay, they'll use either a superscript, or they'll use kind of last name, year. And so it really doesn't matter, but be consistent. You don't want to be using superscripts in part of your paper and then last name, year in other parts of your paper. Okay? So you can always come back to this piece here and check it out. Okay? The other piece that I want to end with is, in this course, it's not my intention at all to make everyone sound the exact same. I do not want you to lose your voice when writing. Okay, that's the great thing about writing papers, is that everyone's going to write it a little bit different. Some people really like one writing style, other people like a different writing style. Okay, and you know, sometimes you'll read a paper and you'll be like, man, that was a really interesting paper, but in actuality it wasn't very interesting at all. It was just the writing style was the style that you like. Okay? Even in science you can have that, but there are some things in science that you should be doing. Okay? First of all, you should be using the correct abbreviations. Okay? And so, looking at this table, if you're looking at this table, go through, make sure that your abbreviations are correct. Okay? If you're going to abbreviate. Okay? The other thing is, make sure that when using common names that you attach the scientific name the first time you mention the common name. Okay? The scientific name is far more important than any common name, and it allows the reader to know exactly what you're talking about. Okay? For example, if I use something like a mallard duck, in the United States, most people know what a mallard duck is. Okay? But if I use mallard duck in other countries, say India, okay, the duck in India is not called a mallard duck. It's called the Indian duck. Okay, and the scientific name is Anas platyranchus. It's the same in both areas. It's the same for both. Same worldwide. The scientific name is recognized, but the common name changes everywhere. Okay? And so that's why I suggest, you know, and all papers should have it. Okay, common name, scientific name. Then after that, you can use the common name as much as you want. You don't have to refer to the scientific name again. Okay. When you start sentences with a number, they should be written out. Okay? And any number under 10 should be written out. Okay? Write reports and write material in past tense, because you've already completed it if you're writing it. So you should write it in past tense. Okay? And then for the most part in scientific writing, we write in first person, not third person. Okay? But that's, it depends on the journal. Some journals, okay, prefer third person, but most scientific writing is done in first person. Okay? All right, so, the part of the lab that you really need to complete, okay, if you're taking this for credit, okay, is to go through these questions. Do you know how to search a library's database? Okay? If not, okay, you need to figure this out. You can contact a local library, okay, and they'll allow you or let you know how to search scientific articles in databases. Okay? Can you use Google Scholar? Okay? This is a search engine for scholarly literature. Okay? What is the difference between primary literature and secondary literature? Okay? You can look this up and figure out the answer to that question. Okay? Do you quote in scientific writing? Okay? If you read through the lab, I highly suggest never quoting in scientific reports. Okay? It's rare that you'll ever find a quote in a scientific article, and if the quote is there, it's really just to highlight a individual that came before you. Okay? So some people will quote Newton, or some people will quote Aldo Leopold, or some people will quote Charles Darwin, but it's not in context. It's not to add to the paper. It's really just to highlight, hey, they thought about it before we did the research. Okay. And then plagiarism, if you're taking this course as credit, I highly suggest looking at what plagiarism is, and then what is going to occur, what's the penalty for plagiarism inside this course. Okay? Alright, so next time we'll hit lab number 2, okay, and we'll talk to you guys later.